we're going to continue on with exponent rules, and I'm going to do a couple things that are more uncomfortable to you, and we're going to talk about zero and negative exponents and give you examples of each. So we're going to do the zero exponents first, the negative exponents second, and then we'll do some examples to show you how the rule works. Zero exponents. Okay? When a base is raised to a zero power, or exponent if you will, the expression is equal to 1. And in the cloud here, I gave you a symbolic representation of why this occurs, and then you just got to remember anything raised to the zero power is 1. So if I had x to the a divided by x to the b, but a and b were the same, they're equal, okay, when a is equal to b, I could write this because they have the same base as x to the a minus b. But since they're the same, when I subtract them, it's x to the 0, which is 1. Now, if you write that down, you say, okay, I have to remember that. But let's just look at it way back at the beginning. If this, the numerator, is exactly the same as the denominator, and you divide two things exactly alike, it's 1. So this is just showing you that anything raised to the 0 power, your powers are the same, so it's going to be 1. It's the same thing on the numerator and denominator. Okay? Let's do a couple of numerical examples. If I have 3 to the 7th divided by 3 to the 7th, same base. If I subtract 7 minus 7, I get 3 to the 0, and that equals 1. And again, those two are exactly the same. If you divide like quantities, it's always 1. Here's one that's a little bit more involved. I have 2 squared times 3 squared. Different bases, all raised to the 0 power. Well, really, right off the bat, I could say, well, if that whole thing is raised to the 0, the whole thing's 1. But let's kind of go through to see why that is. Well, if I did power to the power, that would be 2 to the 0 times 3 to the 0. And then I have 1 times 1, so it comes out to be 1. So whether you look at it as an entire quantity raised to the 0 power, saying, okay, I know the rule now, that's 1, or if you used power to the power, multiplied those exponents, you'd get the same thing. I just wanted to show you why it worked. Negative exponents. Okay, this is one of my favorites. When a base is raised to a negative exponent, it can be rewritten with a positive exponent. So a lot of times when you're asked to do an assignment for me or in any kind of textbook and you're working with exponents, if you get negative exponents, they always say, oh, please write your answer with positive exponents. So you have to know this rule. Now, I have this in a cloud, upstairs, downstairs. This is how I remember it. This is how I teach it. And if you do this, it makes it easy and it's a lot of fun. So let's look at the first one. I have x to the negative a, and it's equal to 1 over x to the a. See how it's negative, and I rewrote it. So basically, if you think about this, if this was over 1, because all numbers are really over 1, all I'm doing is moving that downstairs and it turns positive. So that's where I get the upstairs, downstairs. The negative is upstairs, so if I move it downstairs, it turns positive, but you have to have the 1 up there, so it's a fraction. This, x to the negative a, is equal to 1 over x to the a. They're equal. It's a different way of showing it. Here, this has a negative exponent. This does not. The same works this way. If I had 1 over x to the negative a, if I took that upstairs, it would turn positive. But you just don't need to show the 1. So if you have a negative exponent, you can always rewrite it with positively by using the upstairs, downstairs approach. This is my favorite right here. This is so cool because then you can always move them. Okay, let's do some examples. This will help you understand these rules better. So we're going to rewrite every single one of these after we finish them with positive exponents. So you're going to come up with an answer. The answer will probably rewrite, but I want you to rewrite them and practice with positive exponents. Okay? So I have x to the negative 3 times x to the 0. All right? So what I really have here, I have the same base, so I could add them, or we can do each one separate. So let's do each one separate just so you can see. So I have x to the negative 3 times 1, because this is a raised to the 0 power. And I can rewrite x to the negative 3, it's negative. If you think about it over 1, I can take it downstairs as 1 over x cubed. So that's how I can rewrite that. You also can, from the beginning, look at the same bases. I add them, so you can come right to x to the negative 3. and then make sure you write it, go downstairs. So both ways will work. I'm just showing you how it goes, right? This one here, I have x squared, y cubed, all raised to the negative 4. Before you rewrite these with positive exponents, go through and do the other rules. You can always rewrite it positive exponents at the very end, okay? So we're going to do power to the power. So this is going to be x to the negative 8, y to the negative 12. That's right. That is right. But it's just not written with positive exponents. So what I'm going to do is, if you need to do this, that's really over 1. So this is negative, so I'm going to take it downstairs, take this one downstairs. So my answer is going to be 1 over x to the 8, y to the 12. So these two are the same. It's just that they want it with positive exponents. Okay. Here's another one. I've got parentheses a to the negative 2, b cubed, all raised to the negative 2. Let's do power to the power. So I have a, now look, I have a negative 2 times a negative 2. That turns out positive 4. And then I have b to the negative 6. All right? Now, this is over 1 if you want to do it that way. The 4 is already positive, so it stays where it is. You don't need to worry about that. But we need to bring the b to the negative 6 downstairs. So I can write it. This is correct, by the way. But to write it, I'm going to say a to the 4th over b to the 6th. This is exactly the same as this, but written with positive exponents. Okay, let's do a couple more examples. This is what you will see. Simplify and express with positive exponents. Okay, so I have x to the 3/5 raised to the negative 5 times x to the negative 2/3 raised to the 3. So let's do each one. Let's get rid of the parentheses and do power to the power. Now, if I have 3/5 times a negative 5, you can put that over 1 if you want, but the 5s will cancel, so I'll end up with x, and the negative will stay there, x to negative 3, because those kind of cancel. All right, so I have x to the negative 3 times, again, I have negative 2/3 times 3, so if you can put this over 1, if it makes you feel better, the 3s will cancel, so this is x to the negative 2. All right, now right here, I have the same base. So you're like using your other exponent rules, and if I added those, I have x to the negative 5, which is right, but they want me to write with positive exponents, so we're going to bring it downstairs. So the answer to that is going to be 1 over x to the 5th. Let me box that so you can see it. So that's the answer to that top one. All right? And let's do our last example, and I have this whole... all these factors are raised to the negative 2, and I picked this on purpose because all of these, everybody's pretty good at doing power to the power, but they forget your coefficient. This is really raised to the first power, and so is this. So you've got to remember to do that. So let's get rid of the parentheses and do power to the power. So I have 2 to the negative 2, because 1 times negative 2, x to the positive 6, y to the negative 1, because 1/2 times negative 2, right? And I got, all right, times 3 cubed, okay, because 1 times 3, x to the, and the 3's will cancel, squared, z to the negative 3, okay? Now, let me see if this shows. Okay, now, this is all multiplication. So basically, we're going to just kind of move everything and combine what we can. So I have all these. I have a same base here and a same base here. I have a 6 and a 2, so that's x to the 8th. So if I'm going to rewrite this, we'll have that will stay upstairs as x to the 8th because I've added that. The y to the negative 1, okay, is on the top, but I can take it downstairs and make it positive to the first power. We don't need to show it. So I've kind of used those up. That I have done. Z to the negative 3, I can take that downstairs and make that z cubed, right? So I took care of that. Now here is what I want you to look at. This is 3 cubed. That can stay on the top. And 3 cubed is 3 times 3 times 3, so that's 27. So the 27 can stay on the top. Now this is 2 to the negative 2. So if I take it downstairs, it's going to be 2 squared, or 4. This is what you end up with. So there I have shown you a little bit of each to show you where you can use negative and 0 exponents.